Hello everyone, my name is Bansi Ajudia and I am excited to be here today talk about the advanced DBMS in data modeling. Introduction process of creating a data model for an information system by applying formal data modeling techniques. Second, process used to define and analyze data requirements needed to support the business process. Therefore, the process of data modeling involves professional data models working closely with business stakeholders as well as potential user of the information system. What is data model? Data model is a collection of conceptual tools for describing data and data relationships, data semantic and consistency of constraints. A data model is a conceptual representation of data structures required for database and very powerful in expressing and communicating the business requirements. A data model visually presents the nature of data, business rules governing the data, and how it will be organized in the database. A data model provides a way to describe the design of a database in the physical, logical, and view levels. There are three different types of data models produced while processing from the requirements to the actual database to be used for the information systems. There are three different types of data models: conceptual, logical, and physical. Conceptual: describe what the system contains. Logical: describe how the system will be implemented regardless of the DBMS. Physical: describe how the system will be implemented using a specific DBMS. A data model consists of entities related to each other on a diagram. Data model three elements: entity, attributes, and relationship. Entity: a real world things or an interaction between or more real world things. Attributes: the automatic piece of information that we need to know about entities. Relationship: how entities depend on each other in terms of why the entities depend on each other, the relationship, and what that relationship is, the Cartesian of the relationship. Example for given that customer is entity, product is entity. For a customer, we need to know their customer number attribute and name attributes. For a product, we need to know the product name attributes and price attributes. Cell is an entity that is used to record the interaction of a customer and product. Here is the diagram that encapsulates these rules. First, customer table in customer number, customer name. Second, cell table in customer number and product number and date. In third one, product table, product name and price is purchase of.
Let's start with a few keynotes. First off, by convention, entities are named in the singular form. The attributes of the customer entity are customer number, which is the primary key, or we can say it is an unique identifier. This is often shown with a hashtag symbol. And the second one is the customer name. Now let's talk about the sale entity. It has a composite primary key. That means its unique identifier is made up of combination of the customer number from the customer entity, the product code from the product entity, and the date of the sale. Think of entity as tables, attributes as columns, and instance as rows in those tables. Let's break down with an example. Here the customer table, it has two attributes, number and the name. We have two customer records, customer number 10 whose name is Fred Blocks and customer number 67 whose name is Freda Jones. Now look at the sale table. This shows two sales. Fred Blocks bought product code 101 on 21st Feb 2020. Freda Jones bought product code 452 on 22nd Feb 2020. Lastly, here the product table contains product code 101, which is Flang, priced at $123, and product code 452, which is Blitwort, priced at $34. So for any sale, we can find out which customer bought which product on what date, and by using the product code in the sale table, we can look up the price of the product from the product table. Now let's see the types of data models. There are two major type of data models that are commonly used in the data management. Entity relation models, also known as ER models, UML, which stands for Unified Modeling Language. These models helps us visually represent how data is structured and how different elements in a system related to one another. Let's take a closer look at the entity relationship model. ER models are usually represented using entity relationship diagrams, or we can say ERDs. ERD are one of the most widely used tools in database design because they are easy to understand and capable of being normalized. In this example, we see a university student entity. The rectangle represents the entity. Inside the rectangle, we see list of attributes such as student ID, student name, student date of birth, and student age. The attribute student ID is marked as PK, which stands for primary key. This uniquely identify each student. ER diagrams like this helps in clearly defining the structure of a database before it actually built. Now let's talk about why and when we use data models. The main purpose of a data model is to describe the concepts relevant to a domain, the relationship between those concepts, and the information associated with them. This helps businesses and system analysts have a clear understanding of how data flows and connects. Here is a simple diagram showing the three layers of the data modeling. Conceptual data model handled by business analysts, logical data model created by data architects, physical data model implemented by database administrators. Data models are essential for data modeling data in a standard, consistent and predictable way, getting a clear picture of a core data your business actually needs and identifying missing or redundant data in your systems. So before building any database system, data modeling is a crucial first step. Data models helps in establish a baseline for communication across functional boundaries. That means everyone from IT teams to business managers can understand and speak the same data language. Data models provide a basis for defining business rules. This makes sure your system behave in a way that align with your organization's goals and policies. And finally, using a clear and structured data models makes it cheaper, easier and faster to upgrade your IT solutions. Whether you are scaling up, switching tools or modernizing infrastructure, a well-defined data model simplifies the entire process. Thank you. That's all for today.